All right. Hello. Good morning, everyone. Hello, hello. Welcome to the office hour. It's Thursday. Oops, you might hear a bit of noise coming from outside. They're doing a bit of drilling down the street for me. Sorry, not a whole lot I could do about that noise, except speak louder if I need to do so. Hello, Wangamusa. Hope you're feeling better today. We could carry on today with the KW mini project. Yeah, they had stopped their drilling, I don't know, 10 minutes ago, and now they just had to start back up. Obviously they know now I'm online and so need to carry on making noise. Hello, Deepa. So I only ran the code necessary to do question 3 today, and I didn't try to print out the big dictionary. Printing out a large data structure can be problematic in your notebook. Hello, Dirije. I hope I'm saying your name correctly. Dirije. I hope I'm saying your name correctly. Hello, David. So, again, back to the PW Mini project. So, I only am running the code necessary to answer question 3 so far today, which includes loading the data. Still need to load the data. I still define my code here. I ran this code cell that we defined the other day, which makes this group by field method, because I was using that in question 3. So, reminder, question 3, first we had to basically join our scripts data to the clinic data, because again, I want tuples of the form postcode and total items prescribed in the postcode. Well, the scripts data is the data that has information about items prescribed and numbers of items prescribed. The practices data is what has a postcode. So we had to join one set of data to the other. As I mentioned yesterday, the difficulty or a complication, let's say, it's not necessarily difficult, but it's a complication, is that some practices have multiple postal codes associated with them. And as it says here, use the alphabetically first postal code. And we talked about this yesterday. So, well, this is a natural situation where we can create a dictionary to store this information. So we have a code for practices. Let's remind ourselves again. Practices. Right, practices has a code, which is a string which identifies this doctor's practice to the National Health Service in Britain. A code for a practice might have multiple postcodes associated with it, right? As in, this practice has different locations where they may work. And we want the alphabetically first postcode. So again, a natural situation where, well, I'll make a dictionary. The keys in the dictionary will be the code. The values in the dictionary will be the postcode. Maybe I'll say, the keys are the practice code and the values are the postcodes. And, so I'll make an empty dictionary. I will iterate through this collection of dictionaries here, which is what this for loop is doing. And we just check, is this practice code in my dictionary? If it is, I may need to update that value associated with that practice code. This is what we're doing here. So I'm going to update or possibly update the value associated with that practice code. Right? We want the alphabetically first postcode, so we take the existing value, which we already have, and the postcode of this, new location that we are now examining. Right? Minimizing strings means take the alphabetically first element of this pair. If I haven't found this practice code, well, it's a new practice code. Just add a new key value pair to my dictionary. And so when we're done right here, we'll have a dictionary which will, have a practice code and a postcode. And this minimum right here, right, this is working to give us the alphabetically first postal code. And I said, well, there's a different way we could do this, is we could use this group by field method that we wrote the other day. Take our practices, group by this field. This needs to be a tuple, remember, in this group by field method. And then I need to, iterate over this group by field. And again, I'm going to do a minimum to get the alphabetically first element. Now, Ariel, you say your kernel keeps on dying. Well, only run the code that you need to run to answer question 3. You don't have a whole lot of memory in which to work. Only run the code you need to answer question 3. And importantly, don't try and print out these large dictionaries or these large data structures. Right? Trying to print out this large group by field data structure can be problematic. Right? Even printing out a large data structure takes a lot of memory. So don't print out these large data structures. I mean, you may have to get an idea what they look like, but then that may cause your kernel to die. Well, if your kernel dies, well, start over, run your code again. But again, only run the code you need, and of course at some point, well, you have to remove the code which is causing problems, which is making your kernel die. I mean, I was having trouble yesterday. That's because, say, I was printing out these large dictionaries. It would make my kernel die. I had to go back and start over, running the code again, and I removed the code that was making my kernel die. I said, well, I know what this dictionary looks like now. Well, that gives me enough information to write my code. All right, let's stop printing out this large dictionary. I mean, you could do this, but you have to be careful. You do have enough memory to run the code for these mini projects, but again, only run the code necessary for question 3. Right, but once we get this dictionary of practice codes and postcodes, then we want to join this data. Right, here we're basically making a copy of the script's information. And then what we're doing is we're adding the postcode to each prescription. Right, so adding the postcode. Sorry, just seeing what's going on outside here. Right, we add the postcode, and now we have the information we want. Right, I have. So let's look at our joined data. So joined :5. Right, now I have the information I want. I have items, and I have a postcode. And I have items, and I have a postcode. And items, and I have a postcode. Right, that's the information I want to now use my group by field method that we wrote before. I want to take my joined data, group this joined data by postcode. So I want to find all of the prescriptions that were given by doctor's practices within a single postcode, sum up all the values of items. So we can use this group by field method that we wrote the other day to do this. I want to take my joined data, group by postcode. Again, this will give me a big dictionary. I iterate over that dictionary because remember now my keys in this group by field are basically going to be the postcode. It's a postcode as a tuple of a single value. I iterate over this dictionary by going through the items. K is going to be my tuple of one element that contains a postcode. V is going to be my list of dictionaries, my list of prescriptions that look like this. So now I iterate over that list of dictionaries, extract the items value, sum up all those item values, and I will add a tuple to my items by post list. So at the end of this for loop, my items by post is a list, and it looks like, these list of tuples. So a postcode and a sum of the items prescribed within that postcode. All right, this is what we need. This is nearly the goal at the end here. So I have tuples with a postcode and the sum of the total items prescribed. Now I have to remind myself what we need. We're nearly there. So I have a list of tuples of the form postcode total items prescribed. I want to sort my results ascending alphabetically by postcode. Fine, Python can do that for me. Take only results from the first 100 postcodes. Easy to do, right? I essentially just truncate my list. So what do I need to do here? So I have my items by post. Let me comment out this postal totals, but I'm going to use the postal totals variable. Postal totals. What do? I sort my items by post. I'm going to sort it using the sorted method. This will return a new list. Right, it will sort tuples. It will sort tuples based on the first element in the tuple. And that's what I want. I want to sort my tuples by postcode in ascending order, ascending alphabetical order. And I only want to keep the first 100. I'll just have a look at the first 10. All right, so I sort this list, keep only the first 100 items, which is what I was asked to do. Here's the first 10 items. Oops. Oh, sorry, 10 colon. That's the last 90 items. Apologies. I put my colon in the wrong place. Here's the first 10 items. I could submit this to the grader, and well, my solution matches that of the grader. Is there any question on what I've done here? Right, this is all basically dictionary comprehensions, set comprehensions, list comprehensions, manipulating these Python data structures, lists and dictionaries, and the occasional set. Right, this group by field method is this method that we defined the other day. Let's go back up here. Let's find this group by field method. It's this group by field method here. So data is a list of dictionaries. Fields is a tuple of dictionary keys. Right, these keys should exist for each of the dictionaries in data. Turns a list of dictionaries. This is what this method is doing. So again, data is a list of dictionaries like our scripts or our practices or this joined data that we later created. This fields is this tuple of dictionary keys. So we use this example right here the other day. Took our scripts grouped by BNF name. Don't overlook the comma right here. This is important to say that this is a tuple with one element in it. So we create our keys for the new dictionary by basically iterating over the items in my data, create the keys. We then initialize a new dictionary with our collection of keys and an empty list. And then we iterate over the data again, and again, we'll create a key, and then we append a particular item to the right group. And then we return this dictionary. Right, but of course this is the idea, of writing this function, right? I write this function, I test this function, I see that it's working correctly, and then I just want to be able to use this later on. Because, first we did this kind of by hand earlier. This is when we were grouping things by BNF name. We could use this group by field, and then we wanted to find the drug that had the highest total number of items prescribed over the entire data set. Using this group by field method, again, I construct this joined data set, this joined list of dictionaries. And then we have items right here, and again, then we want to group by postal code and compute the sum of items. Well, this is where we call upon our group by field method. So, I'm not saying that you would have been able to easily write all this code yourself, but with some trial and error, some practice, trying things out, right? This is what you have to do to learn how to do these things yourself. right? It's not like you're really going to break things by trying writing code. Yeah, you might crash your kernel by creating a big data structure and printing it out, but well, your kernel will restart and you could try again. As I said, if your kernel's crashing, it's probably because, well, you're running code that's either unnecessary, you're using up memory that you don't need to do so in order to answer question 3, or it's because you're simply printing out a big giant data structure, which will eat up a lot of memory when it tries to print it to screen. If I don't need a data structure like this items by post, I'm done with it. After I submit to the grader, I could delete that variable. This will allow Python to reclaim that memory, although I think the garbage collection is a little lacking. I could delete items by post. I could delete postal totals. But again, I think the garbage collection sometimes is a little lacking. It doesn't reclaim the memory as often as it should. So, you know, we could start to work on question 4, but again, are there any questions on what I've done here for question 3? So if you're not careful, you know, you could run out of memory when you're trying to do question 4. But again, it is possible to answer this question. We may just need to, you know, go back, restart our kernel, only run code needed for question 4. Let me just remove my jumper here as it's warm. So question 4, it says, all right, we'll combine the techniques we developed to answer a more complex question. So find the most commonly dispensed item in each postal code representing the results as a list of tuples. Now I want tuples. I'm going to have 3 things in these tuples. I have a postcode, a BNF name. Remember, BNF name is the name of a drug, and the amount dispensed as a proportion of the total. So they say sort your results ascending alphabetically by postcode. Take only results from the first 100 postcodes. Fine, we could deal with that later. at the end. Now, so we were grouping by postcode before in question 3. Now I want to make a kind of finer grained grouping. I want to group by the pair of postcode and the BMF name. I want the amount dispensed as a proportion of the total. Well, what does this mean? First, I need to find the sum of the items of each pair for postcode and BNF name, right? Dispense as a proportion of the total. So, you know, if a particular drug was prescribed, if a particular drug in a postcode was prescribed 100 times, and then we want the amount of drugs dispensed in the entire postcode, which, you know, again, we've basically done in question 3, but we might reproduce here again, right? I want, for a postcode BNF name pair, I need to know the sum of the number of items dispensed. Now, then I want to know the sum of the items dispensed in that particular postcode in order to compute the amount dispensed as a proportion of the total. Right, so first things first, well, can I do this grouping by this postcode BNF name and find the total amount of items dispensed for that pair? Now, what we want to do is we want to use our group by field method to help us do this. And we're actually going to help us do we're actually going to use our group by field like a couple of times. So, as I said here, the first step is to calculate the total items for each postcode and BNF pair. Let's call that results total items by post BNF. Although I think we were using actually this grouped by post BNF. Or sorry, all right. So let me remove this and put this here. So if I use my group by field, I take my joined data, because remember my joined data has my postcode in it as well as BNF names. So let's say I group by the postcode and the BNF name combination. right? So I take my join data and group by this pair. Right. So, for example, I have, keys that look something like this, right? It's a postcode and drug name combination. Right? And so, again, what I want to do is I want to iterate. I want to iterate over these keys in this dictionary. I want to sum up the items for each of these pairs, for each pair of postcode and drug name. So consider what is the best data structure to represent total items by post BNF. Now, as I said, if we look ahead, we want to take total items by post BNF and group it by postcode. Well, if I want to group it by postcode, the best way to store this total items by post BNF to use my group by field method is to create total items by post BNF to be a list of dictionaries. Right, so I want to take this grouped data. I want to sum up the items. And again, I want to create a new list of dictionaries if I want to use my group by field method on this new data structure. Right, so again, this is what I want to do. So I want to iterate over a group by post BNF. So I want to create total items by post BNF. So let's create a new cell here. So again, a few ways I could do this. Total items by post BNF. Let's create an empty list. For K, V, and grouped by post BNF. So grouped by post BNF dot items. Oops, that should be a period. Dot items. Well, what do I want to do? I want to say, well, my total items. Let's say just say total. I want to sum the items. Oops, sorry. say V is a list of dictionaries, so D of items for D in V. Right, this gives me the total items. I could say total items by post bnf dot append. I could create a tuple, say. I could say, well, K0, remember my key is a tuple of 2 values and total. Right, so remember K is going to be a key that looks something like this, a tuple of 2 elements. V is going to be a list of dictionaries, something that looks like this. So K is a tuple of 2 items, V is a list of dictionaries. I want to iterate over that list of dictionaries, find the number of items in each dictionary, sum up those number of items, and then say I will create a collection of tuples. We're going to get to a list of dictionaries instead. I'm just showing, kind of my thought process. Total items by post BNF. Right, now I have tuples which have a postcode, a drug name, and a total number of items. Now, I'm going to go back and change this total items by post to not be a list of tuples. I'm going to create a list of dictionaries. Because again, I want to use my group by field method again. My group by field method is taking data which is in the form of a list of dictionaries. So I'm going to still start with an empty list, but instead of appending a tuple, I'm going to append a dictionary where I have postcode, which is my first key. I have BNF name. Oops, let's be consistent. BNF name, which is my second part of my key. And I have, let's call it total items, which is my total that I have computed before. So again, I'm not appending a tuple to this list, I'm appending a dictionary to this list. Now I have a list of dictionaries in my total items by post. Right, this is what we said. The first step is to calculate total items for each postcode and BNF. Call that result total items by post BNF. Consider what is the best data structure to represent this. Because I want to use my group by field method again, this is why I'm creating a list of dictionaries. We're told we should have 141,196 postal BNF groups. So what is the length of my total items by post list? Oops, this is what I have in this assert statement here. Asserts that the length of this list is 141,196. Well, I passed the assert statement, right? No error was thrown. So now I have my list of dictionaries where I have a postcode, a BNF name, and total items. Now, what do I want to do? I want to convert this kind of dictionary into a dictionary where I don't have total items, I have a proportion of total items prescribed in that postcode. Right, I want to take this number 19, I want to divide 19 by the total number of items that were prescribed in this postcode WN71HR. All right, so, well, I actually computed that sum earlier, but I've actually deleted it when I deleted my variables. When I deleted my postal totals, well, so I'm basically going to have to recompute that again. I could do that again. I could write a function that will help me do this. So we want to take total items by post. Right, total items by post, group it by postcode. And again, I could use my grouped by field method to group my total items by post. Now I want to group by postcode. We know you're getting a type error on operand type for point and point. It's hard to say exactly what's going wrong without seeing your code for your multiplication method. Remember, for example, you want to make sure your mul method is defined with double underscore mul, double underscore your mul method. Make sure you're returning a point, a element of type point. If you're multiplying a point and a point, you want a number. Remember, your multiplication method needs to be able to handle multiplying a point by a point, which will return a number. And your multiplication method needs to be able to handle where you have a point and you're multiplying it by a number, which will return a new point. So without seeing your code, it's a bit hard to say what might be going wrong. You could refer back to the office hours where I talked about implementing the mul method for the point data type. You have to do some type checking inside the mul method to figure out is your second element in the multiplication. Is this a point? Is this an object of type point? Is this an object of type int or float, for example? So again, so back here again, we could take my total items by post. I want to group by field total items by post. I want to group by postcode. Total items, oops, by post, sorry, DNF. This gives me this gives me a collection of dictionaries now for each postcode. So for example, if I take this postcode, say grouped postcode, if I give a tuple with one element in it, then again I get a dictionary, which gives me the total, the collection of items that were prescribed in a particular postcode. Let's say now with grouped postcode, we'll iterate over each group, calculate the following fields for each postcode. I might consider writing a function that will do these operations. I want the sum of the total items for all BNF names. So I want to sum up the total items to get a total of total items, which is everything that was prescribed in that postcode. We want the most total items, right? I want to find like what is 32. The highest is I have 13, 26, 5, right? I want to find which drug name was prescribed the most and how many times was it prescribed. Right, I want to think about sorting dictionaries, sorting a collection of dictionaries. That seems a little weird, right? But I have a list of dictionaries. I want to sort that list of dictionaries. I want to sort it by total items. Again, I want the dictionary that has the maximum value of total items. I want to sum up all these values right here. There's one with 112, right? That's probably the biggest, might be the biggest. I want to sum up all of these values to get the total items that were prescribed in the entire postcode. I want to find the dictionary in here that has the highest value for total items. Then I want to know the BNF name. And what we could do, say, is inside this method we could compute a ratio, right? We want the proportion of the prescriptions of the highest prescribed item. A new one, he said you had an issue where practice postal and practice postal alt was not equal. How could you check the error? Well, this might be involved in checking that your group by field method is working correctly. Right? Is this group by field method working? It's doing the job, first of all. And remember that for example, when you use the group by field method, your keys are coming out as tuples of items. Here, these were tuples of single items. I selected the first item out of the tuple to get the string. Maybe this was the issue, right? Your keys are coming out as a tuple with a single item in them. I don't want a tuple right here as this key. I want the code itself. And I get the code by selecting that first element in that tuple for that key. So that may be the issue there. So here, right, the idea, well, is I want to write a method that will do these things. So I'll write a method so let's define find max DNF. So let's see here. Right. We want to, again, think about, well, right, the data that we're getting, the group postcode is going to have a key and a value which is a dictionary. So I'm going to say this is my key and my data, because I'm going to iterate over the grouped data in this group postcode. So what do we want to do? We want to return a dictionary containing, well, I want the postcode. I want the BNF name with the most total items. And let's say the proportion of the proportion of the item with most total items. Probably a better way of saying that. Right? I want to sum up all of these total items within this group. Find the element that had, say, the largest total items, divide by the sum of all those total items to get the proportion. And we're out of time today, so we're going to have to do this next week. But if I could write this method, and then I want to basically apply this method to all of these key value pairs in this grouped postcode, and then I'm nearly there, right? So we want to calculate this ratio, this proportion of the item with the most total items. All right, so this is the number of items for the item that was prescribed the most, divided by the sum of all these items that were prescribed in this postcode. So I want this function to, basically return a dictionary, say, or maybe return a tuple, We'll figure that out. Containing a postcode, BNF name, proportion of item with the most listed items. Because I might include this step 1 in this method here, right? I'll calculate the proportion of the total already. Which I think I'll do that. But again, that'll be for next week. So I wish you all a pleasant day. Stay safe, be well, be nice to other people, and I will see you all next week.